Hello, how are you? I hope this video finds you well. Let's start off with a warm-up problem. This week we're going to be talking about equations and lines. Take a look at this warm-up problem right here. Line M is represented by the equation y equals 4. When you see y equals 4, I want you to think about ordered pairs. Like ordered pairs like 3, 4. Remember that when you are thinking of ordered pairs, the first number is for the x-axis and the second number is for the y-axis. So when this equation way over here tells you that y equals 4, that just means you could come up with a whole bunch of ordered pairs and the second number would always be 4 because the second number is y, like 3, 4 or 1, 4 or 2, 4 or whatever. Now take a look at this question. Which ordered pair, I'm looking at down here, is located on line M? Well, there's a couple ways to solve this. You could take an ordered pair and you can find it on the graph and say, is that on that line that they're talking about? Well, B is not. How about this one right here? C, 4, 1. 1, 2, 3, 4. 1. Nope, that's not either. How about this one? 4, 0. 1, 2, 3, 4. 0. No, none of those are on there. But 1, 4 is. Go over 1, up 4. Bloop, it's right on that line, isn't it? Another way to look at this without even really having to think about it too hard is to see that, remember I told you in ordered pairs, it's x is the first number, y is the second number. And they're telling you that y should be 4. Or in other words, the second number is 4. Well, take a look down there. A is the only one that has a second number of 4. So A has to be the right answer. Don't feel bad if it's not super clear to you right away. We'll go over it a couple more times in class. Check this out. Look at the equation below. If x equals 2, what is the value of y? X equals 2. Thank you very much. You'll plug that right in for x. Okay? When the variable and a number are right next to each other, what does that mean? Does it mean addition, subtraction, multiplication, division? What? It means multiplication. So that really isn't 6x. It's 6 times 2. 6 times the 2 right there. 6 times 2 is 12, minus the 3. That'll get you what y equals. What does y equal? 9. Let's move on. Other types of problems to look at. The first baseman's number is equal to the catcher's number minus 2. They're giving you an important statement right here. The first baseman's number, so we'll just put the first baseman's number B is equal to or depends on the catcher's number A. How would you write this as an equation? Well, they have everything you need except for the last part. You have to recognize that everything in this circle is representative of what's being said in this sentence. The first baseman's number, that's the B, is equal to, that's the equal sign. The catcher's number, that's the other variable, A, minus 2. Well, there's a minus, so what's the only thing it's missing? That's right, the 2. This is one of the harder parts of algebra, but only at first. Is taking a sentence like this and transforming it into an equation like this. The first baseman's number is equal to the catcher's number minus 2. If you say it all fast like that and don't think about it, you might have no idea what to do. But if you take it piece by piece, the first baseman's number, I'll call that B, is equal to, oh great, the word equal, I'll put an equal sign. The catcher's number, well, I guess I'll call that A. I mean, you don't have to call it A, but calling it A is okay. minus 2. No problem. Minus 2. So you can see how this sentence, this long sentence with all these fancy words, can be transformed into this little equation. And all they wanted was what's missing. And in this case, that was that too. Alright. Here, this is why I have the important task of discovering the pattern on every page, because of problems like this. Let's read this together. Mr. N's favorite number is equal to Mr. M's favorite number plus 13. Well, you know, that blah blah blah. Sorry about that, guys. Blah blah blah. Complete the table to show how the favorite number of Mr. N depends on the favorite number of Mr. M. That's a lot if you just read it and you read the words, but they don't mean anything to you. Instead, just take a look at this table. This equation right here, it's equal to what they said in this sentence right here. Mr. N, Mr. N, equal, Mr. M, Mr. M. Plus 13. Plus 13. So you can see how all these pieces in the sentence come down here to create an equation that you can use to create a table. Now they're asking you, what if M was 5? What would N be? Just do what it says to do. Add the 13. 5 plus 13 is 18. What if M was 6? What would N be? Well, it says 19. And after you solve two parts of the table, you should probably see a pattern. 5, 6, 7, 8, 18, 19, 20, 21. And once you discover the pattern, you don't have to worry about continuing to add or subtract or whatever this equation tells you to do. There are 2 stencils on each desk, and there are 2 stencils in the supply cabinet. This table shows how the number of stencils, S, depends on the number of desks, D. Look at this table. Just look at it. It's okay if you don't completely understand the sentence right away, because the table is designed to help you understand. D is 3, S is 8. What happened there? D is 4, S is 10. What happened there? D is 5, S is 12. What happened there? Well, there's a pattern going on. The pattern starts with 3 and 8, but then after that you can see all the rows in D go up by 1, and all the numbers in S, they seem to go up by 2. Let's figure out an equation. S equals 3D minus 2, S equals 2D minus 3, S equals 2D plus 2, S equals 2D minus 2. Well, let's see here. Wow, I don't know about all this 3D, 2D, 2D, 2D stuff. Well, I do, but maybe I don't, like if I'm a kid, right? If I'm a 5th grader. But I do know that every time in this part of the table, S seems to be going up by 2. Going up by 2. 8, 10, 12, 14. So one of your multiple choice answers has that going up by 2 in it. That's subtraction, that's subtraction, that's subtraction. So it has to be this one right here. This is a hard problem if you don't see the pattern. But if you do discover the pattern, the problem's not so hard at all. Alright, last one. Which graph shows this function? Don't be scared by the word function. That just is another way to say equation, kind of. Y equals 2x plus 9. Wow, okay. It's a good thing we have a table right here. We have a table. X is 2, y is 13. X is 3, y is 15. Let's use this table to solve the problem. These numbers in the table are just like an ordered pair. 2 comes from there. The 13 is right next door. And the second ordered pair is 3, 15. I'm getting these numbers for ordered pairs right from the table. So don't freak out. They're coming right from the table. So now look. We look down at these graphs and these lines, and you can see there's points in them. Well, since we know that we can get ordered pairs from a table, all we got to do is search for these ordered pairs on these lines. So let's look for 213. 2, yes, 13. To make sure, let's make sure another dot pops up on this line from the ordered pairs, like 315. 3, that's 3, look, that's 314. Oh, it didn't work out. Only one of them worked out. In order for this to be right, they both have to work out. So it's probably not graph A. Let's look at graph B. Let's see. We're looking for 213 first. 213. Yes, thank you. And now 315. They both worked out. So graph B is the answer. Really quickly, I'm going to give you guys a look at your pop guide. You have a question right there for simply substituting and solving. Down below, they give you a table, and they want you to find the pattern in which equation fits the pattern that you see. Right next door, a table with ordered pairs, and which one of these equations which one of these graphs with a line match the table? Graph A or graph B? You decide. And then I want you to write some sentences for me. Why is discovering the pattern so important? Especially for problems like this one and like this one. Give it your best shot. This is the hardest week of algebra yet. But that's not saying much, because the other weeks of algebra were pretty easy. Weren't they? Alright. Let's do our best on this one, guys. I'll see you in class to go over it if you need more help. Good luck.